In the last lesson, we set up two pins. The first was connected to a switch on the board, and the second was connected to an output that was driving an LED. Hopefully, you got the delay to vary using different CY delay options in your code. Remember, you can always check the course FAQ for help. Controlling an LED from firmware is great, but any micro can do that. Let's start using more of the PSoC configurability. We're going to control an LED from a switch without using any C code at all. First, let's re-enable the hardware connection in the LED pin and draw a wire between it and the switch pin. The wire is green. This tells us it is a digital connection between the pins. When we build this design, PSoC Creator will set up routing inside of the PSoC so that the two pins are directly connected. Try doing that in a fixed function micro. We don't have to write code to set that connection up, and we don't need the API calls from previous lessons. In fact, there's no software at all. The PSoC hardware is doing all of the work. I use a lot of different hardware in my job, and I always struggle to remember whether things like LEDs are active low or active high. I either have to scour through the documentation or write a little test program to figure it out. One of the cool features in PSoC Creator is the ability to add documentation to your schematic. You can show the entire circuit of your design, not just the stuff that's inside of the PSoC. I can do this by adding external components to the design that document how the pin is wired on the board. I just enable the external terminal on the pin component, and then I draw in the LED and the power source or the ground and the current limiting resistor. Now I'll never forget that the LED is active low. I do the same thing on the switch so that I can see that the pin will go low when I press the button. Notice that the off-chip wires and components are blue, so you'll always be able to see that they're not part of the PSoC. They are there for your documentation and won't be built inside of your PSoC. Let's take this simple hardware circuit to the next level and show more of PSoC's flexibility. We'll make the switch act as an LED toggle. For this example, grab the toggle flip-flop from the component catalog and insert it between the two pins. Attach a logic 1 to the flip-flop input, and the LED will now toggle off and on when you press the button. How cool is that? This is a simple example of how we can modify the signal. When you're more familiar with the PSoC, you'll soon be routing signals through multiplexers and different kinds of gates. You'll be able to create sophisticated state machines with our lookup table component. And in some of our next lessons, you'll be controlling functions with a pulse width modulator and with timers. Now it's time for your challenge. If you did the software project from the previous lesson, and you should have, try working that to replace the firmware with the flip-flop. Once you have that working, try driving a second LED. The green LED is attached to P02 on the Pioneer board. But reverse the order of the toggling so the light switches between the blue and the green. For the next example, we will control the LED using one of PSoC's built-in PWMs and a clock. For this project, we will also enable the blinking LED using Pioneer's built-in hardware switch. First, place the PWM component. Double-click on the PWM component to start the device configuration dialog. Click on the button that enables the hardware enable. Set the period to 100 and the compare to 50, and name the component PWM. In this example, the 100 will divide the input clock by 100, yielding a 1 Hz output, and the 50 in the compare value will set the duty cycle to be 50/50. Next, place a clock component. Double-click on the clock and set the input frequency to 100 Hz. Last, wire the schematic together by connecting the switch to the PWM input, the LED to the PWM output, and the clock component to the PWM clock. The last thing that you will need to do is add firmware to start the clock and to start the PWM. You will do that with the built-in component feature, Start. Lastly, build and program the PSoC. You will now have a functioning switch controllable blinking LED. Now there are some things that you can do to make this your own project. And as a challenge, change the design to blink when the button is pressed instead of when it's not being pressed. Also, try changing the duty cycle of the LED by changing the PWM parameters. This can be accomplished by changing the compare value and the period value of the PWM. In the previous examples, you used the hardware of the PSoC to control the switches and the LEDs. In the coming example, you will be using Cypress's proprietary CapSense to control projects.